Coming into a water damaged environment where you see flooded hardwood floors just like what we just looked at, well, that's a common occurrence. You're expected to understand how to dry those floors. But just putting airflow across the top of those wood floors would not be of any value. When you look at the hardwood itself, there's a polyurethane finish on the top. Yes, it makes it look nice, but it's there also as a moisture barrier. So water's not getting into the top of the wood, therefore airflow just blowing across the top of the hardwood isn't going to be of any value. That water is running down between the boards and getting the interface between the subfloor and the hardwood wet. And it's this area right in here. Also, as the water runs down between the boards, it gets the edges of the board wet. So in order to dry that, we have to take the hot, dry airflow to the water. We have to get air to move around this board and across the top of the subfloor in order for it to dry. How can we do that? Negative pressure floor drying systems. There's two ways that we can get air to flow between the hardwood and the subfloor, getting airflow down around those wet edges. That's either to force air in or to extract air out. There are some positive pressure floor drying systems that are available. The problem is that you're only able to force air in from one end. Now, there's going to be a very inconsistent result on how far that air will move underneath the floor. So if you force air under a floor that's very loose and has a lot of gaps in it, well, the air is going to leak out very quickly. And so the air doesn't actually move very far across the floor before there's no more airflow. While there is some inconsistency with a negative floor system, it's consistent enough that we can create a system around it. And for that reason, we look at the negative pressure floor systems for this drying process. There's two components to that. The first is the vacuum pump. And I've got two examples here. All they're designed to do is pull air. They're a vacuum that runs for a long period of time. Now, there's hoses that attach to these. And those hoses go out to the second component, which is a panel. Now, this panel does really only one thing, and that's spread out the vacuum that's coming through those hoses into a much larger area. If we place these panels properly, we can dry an entire wood floor through the use of these vacuum pumps and these panels. Looking again at the two components of a negative pressure floor system, we have the vacuum pumps, and there's two examples here. And you might say, well, which one is the right one for me? You're going to have to look at those yourself to decide, but the things that they're required to produce are CFM, or how much air is flowing through the system, and the second is static pressure, because it's going to require some pressure to pull the air up between the pieces of hardwood, and it also requires CFM because you're losing air, or there's leakage around the panels where we've got it taped down at each crack. So if you lose too much CFM, if there's not enough CFM to make up for that leakage, you'll lose all your pressure. So you need both air flow and air pressure, and that's what these are designed to do. The second piece was the panel. Now, how does the panel lay on the floor? Where do we put it? That is the most critical component to the system as far as the layout is concerned. If you set it up improperly, none of this is going to work. But if set up correctly, the panels will create airflow between the hardwood and the subfloor and create a proper drying system so we can get the water out. Now, in order to understand how these panels should go on the floor, we need to understand what's happening underneath the wood, and then it'll make it clear to us how we need to lay these panels out. When we look at how the wood floor panels affect the hardwood floors, we got to figure out where to put these panels at. We got a hardwood floor, I've got hardwood drying panels. Where do I put them? Well, let's look at what's going on under the floor. First of all, if you notice, you'll see that the air is moving through the floor. It's not moving around all different directions, but rather it's moving through those flutes from one end to the other as we put our panels on the top. You'll also notice that it's moving airflow around the edges, around the tongue of the wood as well. And this is where the drying is going to take place. Now, it does not move left to right across the board. Why would it? The path of least resistance is through the flutes that are on the board. So that's going to affect how we set our panels. Remember, it doesn't move across the board left to right. It only moves down the length of the boards. So now let's go back to the top of the floor. How do you lay out the panels? One of the things I see people do that's incorrect is they take the panels and just kind of spread them out. We're going to do our best job to cover the majority of the floor and put them evenly throughout the room. It kind of looks a little bit like this, a bit of a checkerboard pattern, if you will. This is incorrect. This is not the way to set this up. Now, there's some things that we can set as a standard. Air will move about 3 feet down the length of the boards. So that's through those flutes. But remember, looking underneath, the air will not move left to right. So we don't want there to be more than one joint between the panels across the board. So if you notice in this particular situation, we've got a number of boards moving up and down the photo here. We have a number of boards between the panels. Those areas are not going to dry. The areas that are kind of chalked out there, those will not be affected by airflow from the panels. So when we look back at this particular installation, this is not correct. We don't want our floors to look like that. Again, remember that's leaving some area between the panels where there's no airflow. Even if you set the panels side by side like this, you've got a number of boards between the panels that are not going to be affected by airflow. They're not going to dry. What we want to see is something more like this, where there's not more than one crack or one joint between the panels. That's the way these are set up. Now, down the length of the board, these will move airflow about 3 feet. So we've got no problem with that. We could also take those panels and set them lengthwise like this, because we can have up to 6 feet between the panels. That's because we're going to get 3 feet from one and 3 feet from the other for a total of 6. But no more than 3 feet away from the wall, because remember, on either side of that panel, down the length of the board, it's going to move air about 3 feet. So no more than 3 feet from the wall down the length of the boards, and no more than one crack between the boards. Now, if we look at the bottom of a piece of engineered flooring, you'll note that there is no fluting. There is no fluting to move the air down the length of the board, so that would not apply to an engineered floor. Engineered floors are going to be glued down. They could be a floating floor where they lock to one another, or they're glued to one another. In those type of installations, you cannot think about the air moving 3 feet down the length of the boards, because there is no fluting for that air to move. You're going to have to, if you choose to dry engineered flooring, if you are going to attempt that process, you're going to have to leave very small gaps between the panels, because they will not move air down the length of the boards. So we talked there about the application of the negative pressure floor system on hardwood, and that is the primary application. When these systems are used, most of the time they're used on hardwood floors. But they can also be used on ceramic tile floors. Now, this would be specifically ceramic tile over a concrete board over a wood subfloor. And the principle there is that if water can get under there, then we can get airflow there if we have enough pressure. And these systems make it possible too. The application, the way that it's done, the process is a little bit different, but the principle remains the same. If water's gone there, air can go there, and negative pressure floor drying systems make that possible.